So welcome to video number 3 of my Anycubic Chiron rebuild series. And I know this has been a while, but if you've been playing along at home, you know that I got a new camera, I got some new microphone stuff. There's been a lot of improvements that I wanted to make prior to actually continuing on with this build series. And now that I've gotten to that point, and my COVID is kind of clearing up to the point where I don't sound like I'm drowning, now it's time to continue forward. I wanted to take a minute to talk about heat beds. And there's typically two types of heat beds available on the market for 3D printers. There's DC or direct current, which is what most 3D printer circuitry is powered by. Most of the current inside of a 3D printer is actually running off of DC current. And AC or alternating current, which is typically found in the outlets of your home. A DC-powered heat bed is a little safer than an AC-powered bed, but the trade-off is that there is a requirement for a large power supply to convert the AC to DC, which can lead to a loss in efficiency and overall performance. An AC bed will generally heat up much faster, but it requires a lot more safety measures to be taken into consideration, because if you don't have an AC mains bed wired up the right way, things can happen. So as on most mass-produced 3D printers, the original heat bed on the Anycubic Chiron was this PCB-style heater with a 24-volt DC element. That element was powered by a large 24-volt power supply attached to the Chiron's electrical enclosure. The heat bed was controlled via this MOSFET board, which was feeding a larger current 24-volt supply to the bed than the actual main board could handle. And it was just reading the feedback signal from the main board via this control wire right here. So in essence, this was just acting kind of like a DC to DC relay. And the rest of the electronics were being powered by what is in essence just a laptop power supply. The build surface of the original bed is glass that is permanently bonded to the aluminum substrate that sandwiches both the top surface and the PCB element on the bottom, making other build surface options difficult, if not damn near impossible to implement, and the low voltage of the heat bed meant that getting the surface up to temperature would be rather time-consuming compared to my smaller machines. I wanted to try and eliminate the laptop brick and utilize the larger 24-volt supply to run the Manta board, hot end, and axis drive motors, but that left me in a little bit of a pickle as to what to do with the bed heater. Which leads me to the significance of the number 3, which this is episode number 3 of this build, but this is also a significant number because it not only is the 3rd video of this build series, but it also represents the 3 new sponsors I got for this build series. Those sponsors are PCP Aluminum, JSR Industries, and Wham Bam Systems, which together make up the 3 main components of a brand new heat bed for the machine. PCP Aluminum provided this piece of 1/4 inch thick 410mm by 410mm Alka 5 cast and ground aluminum jig plate, which unlike the stamped aluminum plate you'll typically find on a 3D printer heat bed, is manufactured in a way that there's less inherent stresses caused by the manufacturing process, which prevents the plate from warping under continual heating and cooling cycles, and its non-linear grain structure causes it to expand and contract uniformly in all directions, which will help maintain flatness over the entire temperature range that this bed will see over time. The ground top and bottom surface make it perfectly suited for the flatness required in a large format print bed as well as other industrial applications. I've actually used a lot of jig plate over the years in thermoform mold making and things like that. JSR Industries provided the silicone heating element, which will provide 800 watts of 110 volt AC current to allow the bed to heat up to temperature in only a couple of minutes. Their product lineup consists of both off-shelf and custom-made solutions to fit any heating application. In the case of the Chiron, this heater was a custom design that was manufactured to my specs and sent within a few days of confirming my order. The heater came with the wiring and a thermistor pre-installed, and I'll be adding a thermal fuse as an additional safety precaution during this build process. And finally, the build surface will be Wham Bam's PEX surface, which came pre-installed on this piece of spring steel. The claim to fame is that it has a higher heat resistance than PEI, and it offers a perfectly flat and smooth build surface for prints to adhere to. Now, I would like to take this time to point out that dealing with AC mains voltage is incredibly dangerous. So don't try to follow along at home if you've never received adequate training with working with high voltage systems. If you have any doubts in your abilities, do not attempt these modifications yourself. So before I could actually go and say that this is an actual heat bed, the first thing I have to do is I have to drill and countersink all of the holes for the leveling feet for this thing to actually be used as a heating surface. And then once that's done, I can stick on the heater on the bottom. I can stick on the magnet on the top, and then I can get ready to mount this thing to the actual machine. And of course, there's going to be some additional wiring and circuitry that need to be done on this as well, so stick around and let's have a little fun. So I'll start out by removing the plastic from one side of the plate, and then off camera I'll take a file and I'll knock the burrs off around the outside edges. I'm going to leave the plastic on the bottom side of the plate just to protect the surface from scratches while I'm drilling it out. And then after that I can remove the plastic, and then I can degrease everything and get it prepped for the heater and the magnet to be adhered to it. Next, I'm going to put a little bit of magic marker in all of the locations where the holes are going to go, and this is going to give me a contrasting surface for where the center lines are going to be for the hole pattern. And you can see here what the scribe crosshatches look like. I made a drawing of the hole layout to send to JSR when I ordered the heater, so I'll use a meter stick to double check the positions prior to center punching. Next, I'll center punch the locations where each of the lines meet up, and this will give the drill something to help locate the center of each of the hole positions. I marked all of the locations for the holes. I'm going to drill them out on my drill press. For those of you not familiar with the Ocean of Chaos. So I'm going to start by just putting a little pilot spot on each of the locations using the center drill. Now, I like to go off on a little bit of a tirade about center drills because center drills are not for center spotting for a drilled location. Yes, you can use the very tip, but typically a lot of people like to go up the surface of the cone right here. And the problem with that is that you actually want to drill a pilot spot that has an angle that's greater than the point of the drill. Now the drill I'm going to be using it's about 135 degree, and if it's not 135 degree, which is the standard for a split point, then it would be 118 degrees. And in that case, I would want to use a 120 degree spot drill to pre-spot those locations. Being that the holes aren't really that huge, it doesn't matter too much, but you don't want to go with a pilot drill that has a steeper angle than the hole you're going to drill, because then the outside edges of the drill will bite before the center, and you actually want the center of the drill to bite in before the outside edges. The holes I'm going to be drilling are just slightly over 5 millimeter, so I'm going to drill about 15-20 thousandths oversized, and that should get me where I need to go. So I got my safety glasses on, so let's get cracking. Okay, so far so good. I've got my 4 spots in place. I'll change out my drill. So here's the drill I'm going to be using. You can see right there, it's just slightly over 5 millimeter. It's about 218-ish on the old imperial scale, and 5 millimeter, well, for those that aren't aware, 5 millimeter in inch would be 0.1968. So these are, it's a little bit big, but it'll be fine. Actually, when I drill these holes, I'm going to countersink them for the head of an M5 flathead. And then on the opposite side, I'm going to secure them in place with washers and nuts. So it doesn't matter too much what the hole size is, because they're going to be secured in place anyway. And sighting down where the scratch marks are, it looks like everything is right where it needs to be. And before I go and put anything on here permanently, I'm going to degrease this entire thing with acetone. So the little spritz of oil that I put on there won't make too much of a difference, because it's all going to get degreased anyway. Now I don't have any M5 screws, but I've got these comparable facsimiles. I believe that these are 1024s and they're about the same size. So when I do my countersink, I'll just countersink it to the size of these screws here, and that should get me ballpark what I need to have as far as the actual size of the countersink to put the M5 screws in. I'm going to use this countersink that I've got here, which this is a 90-degree countersink, which is proper for an M5 screw. For metric screws, you would use a 90-degree countersink. And I've had this thing for probably 15 years, and this will probably more than likely be the first time I had to countersink for a metric screw. Most of the other times I'm using inch screws, and the inch screw countersink head is 82 degrees. So this will actually be the first time that I'm sizing it up for the right angle. Now, one thing about the drill press is that you have a little bit of control over what your final depth is going to be, because on the side of the quill there's actually a depth stop that you can set. So once you have it set to the diameter that you want, you can lock the quill stop in place, and then the quill will only come down far enough to get you the diameter that you're looking for, or the depth that you're looking for, just as long as your tool is tight enough to not slip. So it does look like I've got plenty of quill stroke. I don't have to raise the table or anything like that, and then my depth stop will be set accordingly after I countersink the first hole. So I'll just put it about there. I'll set my quill stop, I'll lock it in place, and rock and roll. Okay, the holes are in place, and I tested it out by just dropping this on top of the original heat bed, and it does seem to line up. I just have to make sure that there's no residual burrs around anything. I'm going to hit the top surface and the bottom surface with a little piece of Scotch-Brite just to kind of scuff up the surfaces a little bit to make way for the adhesive. Because once the adhesive goes down onto these, you can't remove it. So this is a one chance only to get this right. So I'll clean this up, hit it with a little bit of acetone, and then get ready to stick the plate down onto it. So I just ran through a test fit, and it seems like everything's going to line up perfectly. I'm going to use the silicone spacers. I had to run to the store and get some long flathead screws. As I mentioned, I didn't have the right screws, but it seems like it's going to work. I'm going to pull this off real quick, clean it up with a little acetone. I wanted to Scotch-Brite the surfaces, but the only thing that I have handy is a steel wool. So I might just run over that real quick and just kind of take the shine off of the surfaces to help with the adhesion of the heater and the magnet. So I'm just going to remove the bed surface from the printer, put the printer back down onto the floor, and then I have a nice working area. So I'm going to give this thing a couple of wipes with some acetone, and that will degrease the surface and give me a better surface to stick to. You can see how dirty it is. And you want to try and get all that crap off before you go and try and stick your mat down. If you don't have access to acetone, you can use isopropyl alcohol. The purer that you have, the better, but I've only got 70%. I also have denatured alcohol downstairs that I could use, but I have the gallon of acetone, so that'll be my final wipe down. So I actually want to do the magnet side first, and then flip it over, and then do the heater side, only because the heater's got the little bumps on the bottom for the wiring and the thermistor and stuff like that, and I don't want to go damaging anything, so I'll put the magnet on here first. So I have to scuff this side, wipe this down really good, put the magnet on, and then I can flip it over and I can put the silicone heater on the other side. And then once that's done, essentially the bed will be ready to install. There are a couple things that I do have to do while I'm installing the bed, but it'll get this to a point where it's ready to pretty much go. So the one thing I really want to do is I want to get the dust off of this table surface now, only because this little shit has a tendency to kick up onto anything that's sticky. And you can see how much there really is on the surface. And that's after wiping it down once before. Okay, so I put some nitrile gloves on to try and prevent any kind of oil contamination. Take my acetone, apply vigorously. So that should just about do it. It's not too bad. You could probably rub this thing until the cows come home and you'd still get a little bit of residue. Now I'm only going to get one shot with this, so I got to make this count. It's basically the exact size that I need, so there's not really much room for margin of error. I'm going to get everything out of my way. Yep, so basically all I have to do is just make sure that when I start this, start off with a small section of exposed adhesive on one side. Make sure I work the air bubbles out, and then I can work the adhesive onto the rest of the surface. Peel back about 1 inch. And there we go. A little exposed on this one side, but it's perfectly along this edge here, so it's not going to be that big of a deal. And I'll just keep working this in a little bit better, but it does seem like it stuck down pretty well. There's no air pockets or anything, and that's pretty much all you can ask for. This side, there's about a 5mm margin around the entire plate, so I'm going to mark that on here prior to sticking the mat down. But I'm running out of SD cards, so I have to change over. Okay, so what I did so far is I just marked my caliper for roughly 5mm and just did a quick little scratch line all the way around, because you can use the tips of your caliper as a makeshift scriber if you really wanted to. Just have to wipe this down. I just want to do a quick test fit, make sure that when it falls onto the lines and my holes match up, and that looks like it'll be okay. Okay, just a little bit more of the same stuff. First off, make sure that the hole pattern lines up. And from there, I'll just flip this over. I'll peel some of the backing away. And then very carefully, and there we have it. It's not perfect, but the holes weren't perfect anyway, and when these go in place, you're not even gonna know a difference. So now from here, I can take the screws, I can take the nuts and washers that I have. I can secure the leveling screws onto the table. Well, first I have to poke through the other side and expose the holes, but I can put the screws in, lock them down, and it's pretty much ready to go. So a good quick way to clean up the holes is actually to just poke a starter from the backside and then take the same countersink that you had from before. Luckily mine has a 1/4" shank and I could stick it into this screwdriver, but basically just go into the hole that you poked and just let nature take its course. And then if you have any kind of proud spots on the top, you could just take a razor blade or something and just smooth over the top of that. So here's a final shot of the bed mounted to the machine with silicone spacers, some M5 stainless steel flathead screws, and the original nylon washers, steel washers, and nuts from the Chiron bed. Future plan is to wire in a thermal fuse and connect the bed wiring to a solid-state relay that will be connected to the bed control output of the Manta board, but as mentioned before, the actual heating will be done via AC mains voltage. Once this is all finished, I'm going to run some temperature tests to see how quickly this monster heats up, but I've got high hopes that it'll be pretty good considering the size of this thing. So my takeaways for this video are that replacing a factory heat bed isn't an overly complicated process. It does require proper preparation and knowledge of basic measuring and hand tools, but if you don't have access to a drill press like I did, a hand drill would work just as well as long as you take your time. The Alka 5 cast and ground plate, by design, is a great surface to start with when building a heat bed because it's not under any kind of mechanical load, and the ground surfaces and molecular structure of the material should make for some really great bed mesh numbers over a long period of time. And we'll see just how well it performs in upcoming videos. Keep in mind that the JSR silicone heaters are available in both AC and DC varieties to fit any application. So if you wanted to stick with a DC bed instead of going with the AC bed like I did, you could do so, and as long as your power supply, mainboard, or MOSFET board are able to hold up, you can go with higher wattages in factory for very little cost. And finally, I'm pretty confident that the Wham Bam Systems PEX surface will be the ideal surface for this machine, and I'm really excited to see how well it performs. So that'll about wrap it up for this video. If you liked it, hit the thumbs up. If you're enjoying this type of content, hit subscribe. And if you know somebody else who might enjoy this type of stuff, share with a friend because sharing is caring. Check out my affiliate links in the description down below at no additional cost to you. Just puts a little bit of catnip into my kitty and it helps my future channel endeavors. If you're on that cesspool that is Facebook, join the group, Elegoo Neptune Series 3D printers, mods, tweaks, and improvements, where we offer 24-hour live chats and community support, do the occasional giveaway, and blatantly abuse the everyone tag. But hey, at least we're not a cesspool of 3D artists like those other pages. If you got 10 seconds to kill, check out my website at www.theferralengineer.com. It's just a whole bunch more of the same stuff, but it justifies the $12 a year I spend on the URL. And once again, thank you to all of my Catnip contributors, both past, present, and future. Thank you for watching, and we'll see you again soon. And of course, there will be some additional wiring and circuitry that need to be done to actually make this work. So stick along. So stick along. And of course, there will be some additional wiring and circuitry that need to be done as well. So stick along. Why do I keep saying stick along?